a refraction through curved surface if the object is in prior medium and the image formed is virtual. That is, we are having a convex curved surface over here. Then let me draw the principal axis of this convex curved surface. After drawing the principal axis, I am drawing an object, and in this case the object is very near to the curved surface. Then let's try a light ray which is traveling in the direction of principal axis. It will pass without any deviation. The next light ray that I am considering is a light ray which is moving like this, and this light ray is trying to enter from rarer medium to denser medium, that is from a medium of refractive index n1 to a medium of refractive index n2. But in this case, if I am drawing, let this be our center of curvature, and let me draw the normal. It is the straight line from center of curvature like this. This is our normal. Then in this case the light ray is not completely refracting and falling over here. Instead, the light ray, it just deviates like this, and if I am extending back this light ray, it will tend to converge at a common point somewhere over here. This light ray, if I am extending it back, it will tend to converge over here. Therefore we are getting an image over here, and the nature of image is virtual since the light ray is tending to converge. Then let's mark the angles. The angle between incident ray and normal, the angle between incident ray and normal, this angle is our angle of incidence. This is our angle of incidence I, and the angle between refracted ray and normal, this is angle of refraction R. The angle between principal axis and incident ray, it is called as alpha, as in our previous diagram. The angle between the refracted ray and principal axis, this is our beta. That is also similar to our previous diagram, the angle between normal and principal axis. Now this angle is called as gamma. Alpha, beta, gamma is there. Then in this case, let's derive. The derivation is as in our earlier derivation. Let's take a right angle triangle. That is, let me mark this point as P. Take the triangle OPC. From the triangle OPC, I is exterior angle, I is equal to alpha plus gamma. I is equal to alpha plus gamma. Then from the next triangle, that is CPI, from triangle CPI, the exterior angle is, what is the exterior angle of triangle CPI? Where can I see that CPI triangle? CPI. The exterior angle is R. R is equal to beta plus gamma. Therefore, R is equal to beta plus gamma. Okay. So then sin I by sin R is equal to n2 by n1, and in this case we could write I by R is equal to n2 by n1 I is alpha plus gamma divided by beta plus gamma is equal to n2 by n1 cross multiplying n1 into alpha plus gamma is equal to n2 into beta plus gamma, then n1 alpha plus n1 gamma is equal to n2 beta plus n2 gamma. Taking gamma to one side, we'll get n2 minus n1 into gamma is equal to n1 alpha minus n2 beta. Then, as usual, since alpha, beta and gamma are very small, tan alpha approximately equal to alpha. Tan alpha is approximately equal to alpha, and in order to find out tan alpha, let's draw a dotted line like this, and this n OPN. OPN, tan alpha is PN divided by ON. What is this ON? ON is approximately U. Therefore, PN by U. Then next is tan beta. Tan beta is approximately beta, since beta is very small. Approximately beta. Beta is very small. And what is tan beta? In order to find out tan beta, we could consider IPN, triangle IPN. In triangle IPN, tan beta is opposite side, that is PN by adjacent side. What's this distance? This is the image distance, therefore this is V. Therefore PN by V. Then tan gamma is approximately equal to gamma, that is equal to, in order to find out tan gamma, CPN, triangle CPN, opposite side is PN by adjacent side is NC, that is the radius of curvature. R. R is radius of curvature. R. Then substituting it over here, we'll get N1 alpha is PN by U plus N2 beta. It's not plus, it is minus N2 beta is PN by V is equal to N2 minus N1 into gamma. Gamma, it is PN by R. Okay. PN by R. Then we could cancel out this PN. Then we could write N1 by U minus N2 by V is equal to N2 minus N1 by R. And let's look at this case. In this case, applying sign convention, what about U? U is negative. What about V? V is also negative. What's R? R is positive. Therefore, minus N1 by U, minus of minus is plus, therefore N2 by V minus N1 by U is equal to n2 minus n1 by r, and we are getting an expression like this. This is refraction through curved surface if the object is in rarer medium and the image is virtual. And this is the expression that we are getting over here. Let me take you towards the previous derivation that we have done. This is our previous derivation. In our previous derivation, the object was in denser rarer medium itself, but the image is real, and in that case our formula was n2 by v minus n1 by u is equal to n2 minus n1 by r, and that is same to n2 by v minus n1 by u is equal to n2 minus n1 by r. Okay, for this derivation, for this diagram, and for this diagram, that is, if the object is in rarer medium, whether the image is real or whether the image is virtual, both the case we are getting the formula as n2 by v minus n1 by u is equal to n2 minus n1 by r. Okay,